All right, so binary base 2 sounds like it should be pretty easy, but it's also a little tricky because you only have 2 digits. So in a binary number system, which is a base 2 number system, we're thinking about grouping by 2, which at first sounds great. I'm great at grouping by 2. 2, 4, 6, 8, there we go. You only have 2 digits. You got to have a 0, which means your only other digit is 1. It's kind of weird. And then the places are powers of 2. So if we listed out some places, we would have our 1's place, followed by our 2's place, followed by our 2 groups of 2 would be 4's, 2 groups of 4 would be 8, 2 groups of 8 is 16, 32, 64, let's do one more for fun, 128. So this would be 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6th, 2 to the 7th. And they just keep going, just like our number system keeps getting bigger and bigger places. So if I were to write a number down, a numeral down in base 2, it can only have 0s and 1s in it. So it would look something like 1, 1, 0, 1, 0, 1, 1. Suppose I wrote that as my number. What does that mean? To understand what that means, again, I have to identify all of the place values. So let's see. I have my 1s, my 2s, my 4s, my 8s, my 16s, my 32s, my 64s. We could count by powers. Sometimes that makes it easier. 0, 1, 2, 3, 4, 5, 6. So to translate this number into base 10, I have 1 times 2 to the 6th and another 1 times 2 to the 5th. We don't really need to deal with the zeros. So my next one I would write down would be 1, 2 to the 3rd power, no 2 to the seconds. There's 1, 2, and there's 1, 1. So without the zeros, that's the expanded form. 2 to the 6th, I have that up here, that's 64. And the cool thing about base 2 though, however, if a place is there, it's just that place. There's no 2 times it or 3 times it. It's just there or it's not. So 64 was there, 32 was there, 16 was not, 8 was there, 4 was not, 2 was there, and 1 was there. So I just write down the places I have. Other ones are zeroed out. What is that up to? We get 2 and 8 is 10, 14, 15, 16, 17. Carry the 1, 6, 7, 8, 9, 10. So it looks like this number right here I wrote down in base 2 is the same as 107 in base 10. We'll go the other way to double check that. Again, going the other way is the harder part typically. How do you read a number like this in base 2? You just read the digits. 1, 1, 0, 1, 0, 1, 1. It's kind of the same way I read a number in base 5. I just read the digits. I don't say the phrase 100 or 1,000. That doesn't make sense in base 5 or base 2. So 1, 1, 0, 1, 0, 1, 1 in base 2 is the same amount of stuff as 107 in base 10. See if we can take it back the other way. We want to take our 107 in base 10 and convert that to base 2. 2 ways to do it. There's the place value method and there's the division method. I'm going to do the place value method first. To do the place value method, I need to figure out how many places I need to do that. So you can list that any way you want. I guess I'll head down this way. So I have my 1's place, my 2's place, and we just keep doubling. 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, and I'm waiting to find a place that's just bigger than the one I'm at. So I don't need that one. I know I need up to 64. Once I get the biggest place value necessary, I just start checking, okay, how many 64s go into 107? And with base 2, it's always 1 or none. So right here, I got 1 that goes in there. I just need to know what the remainder is. 1 times 64 is 64. Subtract. 7 minus 4 is 3. 10 minus 6 is 4. There's 43 left over. So I did the 64, right? That's done. Then I move on to the 32. Okay, so how many times does 32 go into 4, 3? Well, it's either 1 or none, and here I can see it's 1. Subtract, and I get 3 minus 2 is 1, 4 minus 3 is 1. I get 11 left over. So I'm done with the 32. Now, 16 goes into 11. That doesn't happen. I'm going to write it down 0 times. So I move on. 8 is the next place. So I'm done with 16s. I didn't need any. Will you always need the next place? It depends. So 8 goes into 11 how many times? 8 goes in there once. 1 times 8 is 8. Subtract, and I get 3 left over. So 8s are done. 4s, do I need any 4s? 4 goes into 3, nope. So I move on to the next place. 2 goes into 3 once, with 1 left over. Done the 2s, and what's left has got to be my 1s. And so now I have the number written out here. Don't forget about our 1s here. So I found there was 164, there was 132, there were 0 16s, there was 1 8, there were 0 4s, oops, 1 8, 1 in the 8 position, there was a 0 in the 4 position, there's a 1 in the 2 position, and my remainder 1 here means there's 1 left over. And we should notice that is the number we started with over here. 1 1 0 1 0 1 1. 1 1 0 1 0 1 1. If I had started with the 107 and I didn't know that was supposed to be the answer, I would expand that out to check. I'm going to show the other method to do this. So first method is just the place value method. You find the biggest place value and you work your way down. Going the other way, the repeated division method. So that's where I do my short division and I divide upwards. So I'm going to give myself some space. I'm going to put my 2 goes into 107 down here. And then I'm just going to alternate colors on each row. So 2 goes into 10 5 times with nothing left over. 2 goes into 7 3 times with 1 left over. And then we just keep dividing that quotient by 2. 2 goes into 53. 2 goes into 5 twice with 1 left over. Now 2 goes into 13 6 times with 1 left over. Keep on going. We go till we get a 0 at the top. 2 goes into 26. 2 goes into 2 once. 2 goes into 6 3 times. Remainder 0. Again. 2 goes into 13. Let's see, 2 goes into 13 6 times. Remainder 1. 2 goes into 6. 3 times, remainder 0. 2 goes into 3. 1 time, remainder 1. Not done yet. 2 goes into 1, 0 times, remainder 1. We need that 0 quotient so we get that final remainder, and then our number is coming down here. 1, 1, 0, 1, 0, 1, 1. And that all works because we're grouping by 2. It's a little harder with the Mayan because they sneak in that group of 18, kind of messes things up. It's doable, but it's trickier. With Mayans, we just do the biggest place value version. That's the easiest way to go. Otherwise, whichever of these methods works better for you.